Whenever large-scale events like volcanoes, earthquakes, and explosions occur, they produce waves that spread out in every direction and travel through the different layers of the Earth. We call these seismic waves, and in this video, we're going to look at two types in particular: P waves and S waves. P waves are longitudinal and can travel through both solids and liquids, whereas S waves are transverse and only travel through solids. The other difference to know is that P waves are much faster than S waves. By studying how the waves travel through the Earth, scientists are able to figure out its internal structure, which helps them to understand what the Earth is made of. To do this, seismologists can detect the waves using devices called seismometers, and then by comparing their results with those of other seismologists all around the world, they can work out how long it took the waves to travel from the earthquake site to different parts of the Earth. And this gives them clues about the structure of the Earth. Like other waves, when seismic waves reach a boundary between two different mediums, they can be reflected, absorbed, or transmitted. And importantly, when they're transmitted, they're often refracted, which means that they change direction. And remember, refraction happens because waves change speed in mediums of different densities. At boundaries like this one, between the mantle and the liquid outer core, there's a sudden change in density. And so there's also going to be a sudden change in the direction of the wave. Because the liquid outer core itself isn't all the same density either though, as waves pass through it, they're constantly being refracted slightly, and so seem to curve as they slowly change direction. The same thing happens in the mantle, which also isn't all the same density. And so again, the waves are gently refracted and seem to curve. So if we did this for a whole bunch of waves, it would look something like this, with waves bending gradually while in the same section of the Earth, but more suddenly as they pass from one layer to another. Now, this diagram that we've drawn here is only true for P waves. S waves, remember, can't travel through liquids, and so can't pass through the liquid outer core. So instead of our lines going all the way through like this, they'd only be able to pass like this. And this was actually one of the main clues that led to scientists discovering that we had a liquid outer core. The S waves could theoretically pass through the solid inner core, but they can't reach it because it's surrounded by the liquid outer core. This means that for our earthquake at the top of the Earth, S waves couldn't be detected in any of this region, whereas P waves are detected almost everywhere. Oddly though, they can't be detected at these positions, because any wave that passed through the outer core is refracted down here, and any wave that didn't will be refracted up here. So no waves end up in the region in between. You don't really need to worry about the details of these results. The main thing to take away is that scientists were able to discover the internal structure of the Earth by measuring which types of waves could be detected at different places around the Earth. And one of the main things that helped was that P waves could travel through solids and liquids, whereas S waves can only travel through solids.